Hello friends, welcome to Electrical Design Engineering YouTube channel. Today is our first lecture of short circuit analysis using Etap, manual and Excel sheet. This course is prepared on the demand of my subscribers. Before starting the lecture, please subscribe my channel, like and share video on your social media profiles. You can also join our WhatsApp group. The link of the group is given in the description. First of all, we should know what is short circuit. Short circuit is situation in the electrical circuit that allows current to travel along an unintended path with no or low resistance or impedance. Short circuit causes flow of excessive current in the circuit. This is the normal connection of the three-phase motor. If by chance this will happen, that is R phase gets joined with the Y phase, this is the condition of the short circuit. Similarly, in single phase, this is the single phase circuit, and this is the phase wire, and this will is the neutral wire. During normal operations, the current will flow from A to B, B to C, and C to D. If a phase wire and a neutral wire gets joined by some way like E and F, this is the condition of short circuit. Now the current will flow A to E, E to F, F to D, that is bypassing the device. This is the short circuit. What is the need of short circuit analysis in power system? Why we study the short circuit analysis in power system? The various reasons are: first is the system design. Short circuits can lead to excessive current flow, causing overheating of conductors and equipment. This can result in fires or damage to electrical components, posing a serious safety hazard. By conducting a short circuit analysis, it helps engineers determine the appropriate sizing of conductors, protective devices, and other components to ensure that the system can handle fault conditions without compromising safety and reliability. Second thing is the equipment protection. Electrical equipment is sensitive to overcurrent conditions. A short circuit can cause a sudden and substantial increase in the current, leading to equipment damage or failure. Analyzing short circuit helps in selecting appropriate protective devices such as circuit breakers or fuses to prevent damage to equipment and ensure the reliability of the system. Types of short circuit. What are the various types of the short circuit? First is the line to ground fault. This is also called the phase to ground fault. In this condition, one of the line is getting touched with the ground. Second is the line to line fault. In this condition, two lines or two phases got connected to each other. This is called the line to line fault. Third is the double line to ground fault. In this condition, two lines are get connected to each other, then they are get connected with the ground. Third is the three phase fault. What are the input data required for short circuit analysis? For bus data, you should know nominal kV, percentage voltage, type, and continuous and bracing ratings. For branch data, you should be able to know branch impedance, reactance, resistance, admittance, X by R values, transform rated kVA and MVA, base kilovolt, MVA of impedance branches. For unbalanced short circuit calculations, you should also know zero sequence impedances, transform winding connections, grounding types, ground parameters. For power grid, you should know nominal kV, percentage voltage, angle, three phase short circuit MVA X by R ratio. For unbalanced short circuit calculations, you will also need grounding types parameters, single phase short circuit MVA and X by R ratio. For synchronous generator, you should know rated megawatt, kV, power factor, zero sequence impedances, negative sequence impedances, generator type, IEC, etc. type. For induction motor, you should know rated kilowatt by horsepower ratio. You should also know the kV rating of the induction motor, X by R ratio, local rotor current, that is LRC percentage, power factor, local rotor power factor, grounding type is parameters, negative sequence impedance, zero sequence impedances. For a lumped load data, you should also know rated MVA and voltage rating of the load, percentage motor load, percentage LRC, percentage LRC, X by R ratio, short circuit reactance for half cycle. For high voltage circuit breakers, you should know maximum kilovolt rating, rated interrupting capability, maximum interrupting capability, RMS value of closing and latching capability, crest value of the closing and latching capability, rated kilovolt, minimum delay, making, that is the peak current. For low voltage circuit breaker, you should know test power factor, interrupting capability, rated voltage, type, power, model case or insulated case. In the next lecture, we will learn about important terms related to short circuit analysis and also see the calculations of initial symmetrical short circuit current, peak short circuit current, X by R ratio of peak short circuit current, and other things. Thank you.